What's up, math scholars? I rarely start my video during warm-up time, but we're going to go over the ball bounce problem from last night's homework. And it was kind of a challenge. It made you think. Let's see if you guys got it right. Did anybody get 280? 280? That's the answer. And I was having trouble getting 280, so I'll be honest. Here's what I did. I went on YouTube and typed in, how do you do a ball bounce problem that is an infinite sum? And the guy explained it, and I was like, oh, that totally makes sense. So that just proves if you're doing your homework and you're in a bind and you don't know how to do something, YouTube can teach you anything. In fact, I talked to a guy who was a substitute here once, and he told me he learned on YouTube how to help give birth to a baby, and he helped birth his wife's babies at home. Yeah, you can learn everything on YouTube. I don't recommend doing what he did, though. All right, so our ball's starting 40 feet up, right? So that first, I'm going to call this a down bounce. That first down bounce is 40 feet. You got that? Now we're going to have something called an up bounce. The up bounce will be 3/4 the previous height. So take your 40 and multiply it by 3/4. And it's 30, right? So we're going to have an up bounce distance of 30. Then we're going to have a down bounce distance of, you guessed it, 30. And we're going to have an up bounce distance of whatever 30 times 3/4 is, 22.5. Then we're going to have a down bounce distance of 22.5. Then we're going to have an up bounce distance of 22.5 times 3/4. 16.875. And then we'll get a down bounce, and I think you get the pattern that's going on. Yeah. There's something on there. All right, we're back. So let's talk about our strategy we're going to use here. Do you see how, like, the 30, the up bounce and down bounce kind of have a partner? And the 22.5, they kind of have a partner. But 40 doesn't have a partner. So we're going to kind of ignore the 40 for now. What we're going to do is find the infinite sum of the sequence that has a start amount of 30, so an A1 of 30, and a constant multiplier of 3/4. So let's do our infinite sum equation from yesterday. The infinite sum would be 30 on top, 1 minus 3/4 on the bottom. If you type that in the calculator, that's going to give you, I believe, 120. But let's type it in just to make sure my memory is serving me correct. 120? All right. So when you do that infinite sum, you basically find 30 plus 22.5 plus 16.8. You're only finding, like, the up bounces. You have to double that number to account for the down bounces as well. So that gives you 240. And then, if you remember right, I said we're going to ignore this 40 till the end. Now we're going to use it. So that's how you get the answer of 280. Isn't that crazy? So you have to have the concept of the down bounce and the up bounce, and then you have to add the 40 at the end. Crazy, crazy, crazy. All right, I want to show you guys a super cool trick. It's basically your birthday. You're going to be so excited I'm going to teach you this. Happy birthday! I'm going to teach you about the secret button that I've been keeping a secret up until now. There's actually a summation button in the calculator. So you can find it by going math, up, up, up. You actually need 4 ups if you have a color calculator. You need 2 ups if you have an older calculator. Math, up, up, up. It's called summation. So it'll give you a bunch of little boxes, and you can just put things in the boxes. So like in this box, let's place an X. In this box, let's place a 5. In this box, let's place a 13. And then in this box, let's place a x to the 5th plus 2. And it'll do it for you. Yay. I know. We always get the angry mob. Why didn't you tell us that in the first place? Well, we want to teach you how the shortcuts work. We want to teach you what summation actually means and how to find it using tables. Lexi might not have it because you have a really, really old calculator. So you have one of yours like this that you actually have it. Alrighty, so we're ready to learn the lesson. It's 7.5 day 1, recursive sequences, recursive rules, recursive equation. So first off, we're going to talk about what an explicit equation is, an explicit rule. Explicit is an equation that can be used to generate any term in the sequence. So if I want the 50th term, all I have to do is put a 50 in for n. So you jot that definition down, and I'll give you an equation of that would be in explicit form. Yeah, I'm recording. I'll hit pause while the students write down the definition. All right, so I did write down this example problem here. This would be an explicit formula of a geometric sequence. We did this earlier. I'm pointing to the formula on the board right now. What's the first term? 6. What's the constant multiplier? 2. And I could find the 50th term so easy. How would I do that? How would I get the 50th term? Stick that 50 in for n. I'm guessing the number would be humongous because these grow so fast. It's probably in scientific notation. I'll go ahead and do it just for fun real quick. Oh yeah, definitely scientific notation. 3.38, I rounded that to 10 to the 50. That's your 50th term. All right, what we're going to do today is going in the other direction with things. We're going to do recursive rules. Recursive rules will give you the first term, but then tell you how to get the next term from there. So the only way for you to get the 50th term, it's going to sound crazy, is find all previous 49 terms. So it's not super user-friendly. You'd have to literally click enter 50 times to get to the 50th term. Even though it's not the easiest to get to the 50th term, we're still going to learn about it. Okay. All right, here we are. So I did write a little example problem up here to talk to you how this would work. They're going to say this is a recursive sequence formula. And they're going to say, let's list out the first 6 terms. You can list them out horizontally across your paper, vertically, like with a chart. It's totally up to you. I'll just do horizontally. What do you think the first term is? I bet you can figure that out. 5. Because they're saying A1 equals 5. All right, so the first term's 5. I think we sorted that out. To get to your next term, here's what you're going to do. You're going to take 2 times the previous answer. So that would be 5, 2 times 5. And then you will add 7 to it. So what is 2 times 5 plus 7? 17. Good. Makes sense? To get to the next term after that, you will take 2 times the previous solution, which is now 17. This guy's always changing. Plus 7. So 2 times 17 plus 7. 41. Hello? It was given to us. Everything up here had to be given to us, because if they don't start us off with the first term and give us a formula of where to go from there, we couldn't generate a sequence. Okay, so 41. To get to my next term, I'll do 2 times the previous solution, so 2 times 41 plus 7. 89. And so forth and so on, and that's how you generate your sequence. Now, you want to know a quick way you can do it in the calculator? Yes, we do! So pull your calculator up. I'm going to make this slightly smaller so you can see the formula while you can see my calculator. Oh no. Go ahead and clear everything on your calculator so you're ready to rock. So to do this on the calculator, you'll click 5 enter to initialize the sequence. And basically say, hey Mr. Calculator, we're starting with 5. Then you'll do 2 times second negative key. It literally plops the answer in there, and that basically tells my calculator, hey, put whatever the previous solution is, put it right here. If the previous solution's a 5, use it. If the previous solution's a 17, use it. And then plus 7. So this number will always be changing, in other words. So this will be term 2. Hit enter. That'll be term 3. Hit enter. That'll be term 4. Hit enter. That'll be term 5. Isn't that sweet? How you fly. It just flies down through as long as you utilize the answer button. Alrighty, let's try this one with our calculator helping us this time. How would I start it off? What would I do with my calculator? -5, enter. So that's your first term. Go ahead and list it out as first. We're going to list our first 6 terms. Then we're going to do 3 times second answer key plus 1. When you click enter, that'll be your second term. What is it? Click enter again, that's your third term. Enter again, that's your 4th term. 5th term, and 6th term. So make sure you can get what I can get. If not, talk to a neighbor about what you're typing in wrong. Because maybe your neighbor could spy your calculator and tell you what you're doing wrong. Now, do you think a true mathematician, when writing out a math textbook, would literally draw a picture of an answer button? Not at all. There is a notation they will use instead of an answer button, and it's a subscript. So instead of an answer button here, they're going to have the subscript n minus 1. So if you ever see a subscript of n minus 1, it basically means go back to the previous answer. Make sense? What if you would see a subscript n minus 2? What do you think that would mean? Go back to previous answers. We'll see one of those later on today. So this actual problem would have looked like this in a textbook. Clear? When I see the n minus 1 subscript, I draw a box around it, and that's just a way to trigger my brain to say, oh, use the answer button on the calculator. Go back to here? Sure.
It'd be the same.
So this is the same deal, it's just written more in a horizontal format instead of a vertical format. But what do you guys think the first term is? A 1. Everyone agrees with that? Okay. Let's go ahead and use our calculator to generate the next 5 terms. We'll have 6 terms total listed. How do we do it? You talk me through it. 1, enter. And then 3 times previous answer plus 4. Because this a n minus 1 subscript means previous answer. So term 2 is a what? Did you get 7? It's awkwardly silent. We got 7. Perfect. Term 3, did we get 25? And then 79. That's term 4. Term 5, 241. Term 6, 727. Easy enough? You ready to get to the challenging ones then? The challenging ones are the ones where you can't just use the answer button and fly straight down the list. Okay? So let me locate one. This is real brief. You don't need to write this down, but just says arithmetic sequences and geometric sequences could be written recursively because they just add a constant amount and multiply a constant amount each time, which that makes sense. I'm looking for a challenging one. Haha, found a challenging one. Go ahead and jot it down and we'll explain what all the subscripts mean. So right off the bat, you notice something different, and that is they're starting us off with 2 terms. Strange. Normally they only start us off with 1 term. There's a reason. So we got that t subscript n minus 1. That means go back to the previous term. And that's when you can use that answer button in the calculator. But what do you think t n minus 2 is? Talked about a few minutes ago. Go back to previous. 2 terms previous. So if I go to find term 3, basically means go back to term 2 to grab this guy, so that'd be a 6, and go back to term 1 to find this guy, so it'd be a 3. So to get term 3, I do 6 plus 3 and get 9. Does that make sense? Let's try term 4. To get term 4, I go back 1 term, which would be the 9, so I'd grab him, and I'd go back then 1 term before that to get the 6. So term 4 would be a 15. So nod your head if you get it, because this is very weird. So to see if you truly get it, I want all you guys to find term 5 all by yourself. And term 6. Get a little wild and do term 5 and term 6. If you're lost, look at the board and I'll do it right here and you can watch me. You don't have to. If you can do it all mentally, you can just list the numbers. How we doing? 24 was term 5, 39 was term 6. Give me a thumbs up if you're good. Ask a question if you're not good. Alright, I'm going to find one that's a little bit challenging in a different way. Yeah. Alright, hello video people. So the last one, you could not just use your calculator because there's no button on the calculator that says go back 2 terms. Similarly, there's no button on the calculator that will handle this n right here. So let me explain what our formula is wanting us to do. They're starting us off with term 1. Term 1 is 1. Great. To find every term after that, you'll go back 1 term. That's what this means. Go back to the previous answer. But then add on n. What do you guys guess n is? whatever term you're on. So if you're on term 5, n is 5. If you're on term 4, n is 4. So it'll be constantly changing. There's no button on the calculator that can handle this. You're just going to use your own brain to do this one, just like on the last slide. So to do term 2, you'll take the previous term, which was 1, and you'll add on n. And if you're on term 2, n is 2. So that answer would be 3. Make sense? Let's try term 3 and 4 together, and you can do 5 and 6 yourself. So term 3, you'll go back to the previous solution, which was 3, and you'll add on n. And since I'm on term 3, n is 3. So looking like my answer is a 6 on that. Nod your head if this makes sense. Okay, let's try term 4 together. You'll take your previous term, which was 6, you'll add on n, which was 4. That's a 10. So just to kind of check your understanding, go ahead and do term 5 and term 6 all by yourself. Whenever that happens, my board is not lined up real well. Oh, goodness. So term 5 is 10 plus 5.
You get 2.
The 2? Like right here?
Yeah.
So 2 is n, and n is whatever term you're currently on. So I was on term 2, so my n was 2. When I'm on term 5, my n is 5. And when I'm on term 6, my n is 6. The previous answer was 6. How are we doing on getting 15 and 21? Good stuff? All right, I'll pause and let you catch up, and we'll do our graduation problem and be done. Okay? All right, we're going to go ahead and see if the students can graduate the lesson. This is a pretty easy one. I think you won't have too much trouble. All right, so I'll walk you through how to do this in the calculator. You do -3, enter. Then you do second negative key, which brings your answer button up in front of you, squared. And then enter, 9, enter, 81, enter, 6561, enter, enter. And the very last one is so big it's in scientific notation. Okay? So, your homework is right. Of course, it's not going to come out. Right there. Page 470, 2 to 12. All. Okay? So thanks for watching the video today. See you later.